Hi there. In the last video, we looked at transformations of the base logarithmic function. And this video, we're going to actually go ahead and sketch one. And the sketching is not as scary as it looks, I think. But knowing this transformation, knowing the sense of transformations, I guess, will allow you to understand what the graph should look like, so that when you're calculating stuff, it kind of all makes sense. I think that's the best way to look at it, really. Technically, you could get away without even thinking about it, but it often leads to mistakes because it's not what you're expecting. So looking at this particular example, I've got y equals 3 log base 2x plus 1. So there's a couple of transformations there, and it's not in exercise 13G, this particular example. And the examples are easier or harder than this particular one. But I thought this middle of the road example might help. So we can see that there is no reflection, that there is going to be a dilation in the same direction as the y-axis. There's going to be a translation to the left because it's plus 1, so it'll translate to the left. So if we remember our transformations, I might just get that zoomed out. If we remember our transformations, we can sort of see that this horizontal translation means that there's going to be a y-intercept issue here. It's going to affect the asymptote. It's going to affect the x-intercept. It's going to affect the other point as well. And for dilations, the other point is affected as well. So those are the sorts of things we should be looking at. So let's have a look at it, and I'll just try and explain how we go about doing each bit. How do we work out the asymptote? Well, given that the asymptote is where the argument in the base function, which is x cannot equal 0 effectively, because as x approaches 0, y approaches negative infinity, then we effectively just need to work out what x plus 1 equals 0 solves as. So we go x plus 1 equals 0, and that gives us x equals negative 1. So that's the equation of the vertical asymptote. For the x-intercept, we're just going to use our usual knowledge, which is that for an x-intercept, let y equals 0 and solve. So we go 3 log base 2 of x plus 1 is equal to 0. Divide both sides by 3, and we get log base 2 x plus 1 is equal to 0. And now we can use our log laws, or our basic log function, which means that we know that that means 2 to the power of 0 equals x plus 1, and 2 to the power of 0 is 1, right? So we're going to end up with x is equal to 0, i.e. 1 minus 1 is 0. And as you know, I like to put the point over here to the side. Y-intercept, we're going to use the same sort of logic here. We're going to say y is equal to 3 log base 2, 0 plus 1. And now we're going to solve for that. So log base 2 of 1 is, well, 2 to the power of 0 equals 1. So this is going to be 3 multiplied by 0, which is 0. So the y-intercept is also 0, 0, which you'd kind of expect, right? We actually worked it out here, but I just wanted to do it out of a sense of completion. Now, I wonder why I chose x equals 1 for my other point. Maybe think about it. Pause it and think about it if you can, but I'm going to move on. So at x equals 1, why did I choose that? Log base 2 of whatever the argument here, I want it to be a nice simple number so I don't have to reach for my calculator. So any power of 2 here would be helpful. And the easiest power of 2 is 2 to the power of 1. So 2 to the power of 1 is 2. So how do I make x plus 1 equal 2? Well, by setting x equal to 1. So at x equal to 1, y equals 3 log base 2, 1 plus 1. And log base 2 of 2 is 1. And that equals 3. So at x equals 1, y equals 3. So there's my critical points. I'll go down to slide 8 and draw it. So first of all, my axes in. Oops, I might just go a little bit further towards the middle because I have translated that. I'll put my vertical asymptote in, which is about here. So it's x equals negative 1. I'll now draw my line in. I know I have to hit x equals the origin, and then it stretches off like that. So there's 0, 0, which I don't really need to mark in because it's the origin, right? But I'll mark in my one other point, which was 1, comma 3. And there's my graph sketched. So that's basically it. I mean, we can throw more transformations at you. We can put a reflection in, all that kind of stuff. But it's probably worth you just thinking about it from the point of view of these 4 critical points. Where's the asymptote? Where's the x-intercept? Where's the y-intercept if it exists? And remember, it only exists if there's been a horizontal translation. Where's one other critical point? I reckon once you've done all those 4 things, the reflection will take care of itself anyway. But you can sort of keep track of what transformations have been applied so that what your sketch looks like confirms what you know about your transformations. Okay, have a go at the work from exercise 13G.